Well, fellows, I think the second section here in Chapter 9 is probably the easiest section of the entire year because you all know what the Pythagorean theorem is already. Okay, so we're just going to go through it really quickly, and you'll get some time to work on it. So, Pythagorean theorem obviously has to do with just a right triangle. Okay, really important. Right triangle. Got to be a right triangle. Don't forget it. Can't be anything but a right triangle. Okay, so we've got the side lengths we call A, B, and C, where C is always the hypotenuse and A and B are the legs. And the formula we could get from this to help us identify the lengths of these sides is A squared plus B squared equals C squared. Okay, you guys probably recognize that. One thing to note about this is a Pythagorean triple. So if you see this terminology, you will see it in the practice set. A Pythagorean triple is a set of all positive integers. So if all of these numbers, A, B, and C, all come out to be positive integers, like for example, A is 3, B is 4, C is 5, that's the most common Pythagorean triple, then that's called a Pythagorean triple. Right? If one of them is a square root or a decimal or anything like that, then it's no longer a Pythagorean triple. Okay, right into the example. So most simple one right here up top, we've got our A and our B and obviously C. Okay, so we're going to use our Pythagorean theorem, A squared plus B squared equals C squared. Okay, A is going to be 4, so 4 squared. B is 12, so 12 squared equals C squared. So we have 16 plus 144 equals C squared, right? And 16 plus 144 is 160. So 160 is C squared. Take the square root of both sides. Okay, so the squared goes away, and we're left with C is square root of 160, right, which is the same as 16 times 10. When you reduce this, you're going to get 4 root 10. Okay. Next one here, we're going to work backwards just a little bit in number 2. Not overly complicated, but, right, we have our C now, so we need to find A squared, right? Let's call 10 the B, X is our A, and 20 is our C. It's always good to label those so you don't mess up which side of the equation you're on. Okay, so our A squared is X squared, B squared is 10 squared, C squared is 20 squared. Okay, so we have X squared plus 100 equals 400. Subtract the 100 and X squared equals 300. Square root both sides to get rid of the square root, or the squared, and X equals, when you reduce it, right, you guys should be able to reduce on your own at this point, you should get 10 square root of 3. Okay? Number 3 is, and 4 are the more difficult ones, okay, so these are the more interesting, I guess, or challenging problems from this section. So number 3 here, all right, the reason this one is basically what we're going to try to find, we're going to try to find, let's say we'll find AB over here. Okay, so that's going to be X. All right, we're going to have to, there's an extra step that's going to have to go into this. Now, one thing you might notice about this is you probably look and you see, well, we just use that geometric mean stuff that we just learned in the last section. The reason you can't is because although you have the altitude drawn here, this big triangle is not a right triangle. Okay, you can only use those geometric mean things if you have a right angle right here. Okay, so because you don't have that, you can't use that. But we can use the Pythagorean theorem because we have 2 right triangles, right? These 2 little triangles are both right triangles. So in order to do that, we need to find this BD first. All right, we can call it H. Okay, we need to find that. So if we're just looking at this little right triangle, right, we've got A, B, and C, and we can solve for H there. So 3 squared plus H squared equals 5 squared. Okay, so we'll have 9 plus H squared equals 25. H squared equals 16, and H equals 4. Okay, so we know that H is a 4. We can just write 4 over the top of it. Okay, so now we can do the Pythagorean theorem a second time to find our X. Okay, where 4 is our A, 7 is our B, X is our C. So we have 4 squared plus 7 squared equals X squared. So 16 plus 49 equals X squared. And X squared equals 65. Okay, take square root of both sides to get our x by itself. So x equals the square root of 65. And you can't do anything with that, so that's the final answer. All right, last one here is not overly difficult, okay, but one thing, just a minor thing you need to look for when you're doing problems like this is you gotta know what these measurements here all represent. So we have the 12 here and the x, all right, but we're just looking at this triangle, right? Because that's the right triangle, because it has to be the right triangle. So in order to solve this problem for x, we have to know what this bottom is here, okay? And it's half of the whole 10, right? If the whole thing is 10, half of it, right, we're cutting it in half there, so it's going to be 5. So because of that, we can create our equation, 5 squared plus x squared equals 12 squared. So 25 plus x squared equals 144. Subtract the 25 from both sides, and we will get 119. Yeah, that's right. Okay, square root of both sides. Get rid of your squared, and x equals the square root of 119, which you can't reduce at all. Okay, so that's it. I'll see you guys in class.